So now it should be working. See that little red dot right there? As long as that red dot right there is going, that means I'm recording. So we're good to go. All right, let's talk about this. Let's draw a little graph. It's not really like any kind of specific graph. It's just kind of a very general graph, just to kind of explain what the end behavior is. It's the end behavior of the graph is what we're talking about when we do this. So I'm going to try to draw it as close as possible to what I have. So this kind of comes here, it kind of goes there. Oops, it goes up there like this, comes back down, and it goes back up like this. All right. Crazy looking thing, all right? Probably represents something somewhere. But all we're concerned about, I don't care about all the stuff that's going on in between. Now, in the next lesson, we will. Okay, we're going to talk about this point where it dips down to, this point where it comes up to, another one dips down to here, another one comes up to here. We're going to talk about those in the next lesson. But today, we're just worried about the endpoints. Okay, so this goes, as we go to the left, this goes what? Down. As this goes to the right, this graph goes what? Up. But instead of saying left and right this time, we're going to talk about infinity and negative infinity. So instead of saying to the left, what is this direction? That's negative infinity. And down, instead of saying down, what is that direction? That's negative infinity. Going to the right would be what? Positive infinity, and going up would be positive infinity. Everybody with me on that? So the question would be, describe the end behavior of this graph. So here's what you would say. You would say as x goes to, I put an arrow there, okay? As x goes towards negative infinity, then y approaches, let's say that instead of goes towards, let's say approaches. That's a much better math word. That's supposed to be an O-A-C-H-E-S. Okay, it's a calculus word that you're going to hear when you take calculus. All right, it approaches. So as x approaches negative infinity, what does the y do? Y approaches what? It goes down. What did we say down was? Negative infinity. So that's this end behavior right there, because it just keeps on going. Everybody see that? Right? What about this one? How would we say this? We would say as what? As x approaches what? Positive infinity, then y approaches positive infinity. And that's the end behavior. That's the kind of stuff they're going to ask you to do. Right? Is just look at a graph. The first chunk anyway of your homework is going to be look at the graph and just tell me what the end behavior is. All right? Now they have another chunk of problems that says use a graphing calculator. Now in here I did not require you to have a graphing calculator, but you can use the Desmos app, okay? And if you have to do it on a quiz or a test, I'll let you use it on a quiz or a test, okay? But I'll be walking around making sure you don't put photomath on there and all that kind of stuff, all right? So, but I will let you use the Desmos app. If you don't have it, get it, okay? Put it on there. Learn how to use it. Everybody understand that? Okay, so I will let you use your phones if you have to use the Desmos app, all right? And you kind of have to be on your honor a little bit that that's the only thing that you're going to use on your phone. Everybody pledge? Put your hand up. I solemnly swear. Okay, good. Pledge allegiance to the Desmos app. All right, so let's take a look at this. Here's another one. I got to get through this kind of quick here. Well, I've got 15 minutes. I got time. Don't want to rush it too much, but I do want to get through. Watch this. This is a graph that you've seen before. All right. What kind of graph is this in general? It's a what? It's an x what? Y x cubed. Right. This is an x cubed graph. Okay. So this is an x cubed graph. So I'm not going to write it down again because of time. But as x approaches positive infinity, what does this approach? Positive infinity. As x approaches negative infinity, what does y approach? Negative infinity. Okay? So this would be like y equals x cubed. What does it look like if I did y equals negative x cubed? What does that do? You should know that already. It basically flips it, right? Okay, it makes it go like this, and it makes it go like this. So again, what would I say? As x approaches, if I want to describe I keep saying endpoints. What is it again? End behavior. If I want to describe the end behavior, as x approaches what? Negative infinity, then y approaches positive infinity. As x approaches positive infinity, then y approaches negative infinity. Everybody see that? All right, that's if you had a negative x cubed. And the cool thing about this is if you had some crazy looking function, if you had like negative 3x cubed minus 2x squared plus 7 or something like that, this is still basically, not exactly, but it's still going to basically look like this yellow one. All right? It might be shifted a little bit, but it's going to have that same end behavior. So if you had something like this, here's what I would do. I would do a little graph of my own, and what am I looking at? I don't even care about the 3. All the 3 does is what? Squishes it or expands it, right? All right, so I'm just looking at the negative and the x cubed. What does a negative x cubed do? It looks like this, and it looks like this. So if they say describe the end behavior, what am I going to say? As x approaches, let's go to the left first. What? Negative infinity, then y approaches what? It goes up. As x goes to the left, y goes what? Up. But we don't say left and up. What do we say? As x goes to negative infinity, then y goes to what? Talk to me. Positive infinity.
How do we know which one is the x and which one is the y?
This is the x and that's the y. Okay? As this goes to the left, as this point goes to the left, what happens to the y value? It climbs up, doesn't it? Okay? So as x goes to the left, y climbs up, and that's what's going on here. Now, as x goes to the right, what's happening to the y value? It goes down. But we don't say that. We say as x goes to what? Positive infinity, then y approaches what? Negative infinity. So that works with this as well. All right? Even though it looks crazy and it's got all that stuff on there, and that'd be really, really hard to graph by hand, okay? But at least I know what the ends are going to do, okay? I know the behavior of the ends, okay, is going to go like this and like this. If we had some extra time, we'd probably put that on Desmos, look at it, and you can see that it mirrors, kind of, it mirrors this basic graph, all right? You with me on that so far? All right, so here's what we're going to do. I'm going to write these, this is in the book, but I'm going to write it down so you can, and talk about it so you can see. So I'm going to do 4 different things here, just to describe the end behaviors of these graphs. So let's say you had a graph that looked like a squared function. You should know what a square function looks like now, don't you? What's that look like? Give me one word. Parabola. Good. All right. So like that. And again, if you had any numbers in here, like a 3x squared minus 2, if you had anything like that, even a 1/2 x squared minus 7 or something like that, it would all have the same basic behavior. The ends would have the same behavior. So anything with an x squared, what's this going to look like? This is going to be as x approaches, let's start with the left first. Let's go negative infinity. As x approaches negative infinity, what does the y approach? Positive infinity. Let's say negative positive, okay? As x approaches what? Positive infinity, then y approaches what? Positive infinity, okay? So that's an x, that's an x squared function, all right? So what do we know here? First of all, what's cool about this as well is this is what kind of a number? It's an even number, isn't it? Anytime you have any functions when your lead variable, okay, your greatest variable is an even function, it's always going to do this. The ends are always going to do this. It's not going to look exactly like a parabola, But I could have like x to the 8th plus 3x to the 7th plus 2x to the 6th, blah, 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 all the way down. And I know what my end behavior is going to do. Okay, I know when I go to the left, it's going to go up. I know when I go to the right, it's going to go up. Just because I'm looking at that number right there. So that's kind of makes it easy, doesn't it? All right, they can give you some crazy looking functions, and you should be able to tell what the end behavior of that function is going to do. All right? You could put that. You could just make up stuff. I was doing it myself on Desmos. I was putting some crazy formulas in there, not formulas, but functions in there, and I was seeing what would happen to the end behaviors. And sure enough, if this is an even number, okay, this is going to both go up. What if it was a negative? Oops, let's just do this. What if it was still an even function, okay, an even exponent, I should say. I shouldn't say even function, but an even exponent. But it was a negative. What if it was f of x equals negative x squared? What's going to happen to that graph? Oops. Yeah, all it does is flips it down, okay? So if it's a negative, it looks like this. And again, let's do the end behaviors. That's what we're concerned about. That's what this portion of this lesson is all about, the end behaviors. So what do we start off with? As x approaches, let's go to the left first. As x approaches what? Negative infinity. Then y approaches what? Negative infinity. Good. As x approaches positive infinity, y approaches what? Negative infinity. Okay? See it? As x goes to the left, then y goes down. As x goes to the right, y goes down. That's what this stuff is saying. And that's the end behavior. So when they ask you on a homework, what is the end behavior, then that's what you're going to say. That's what you're going to write down. All right? Let's do ones with odd numbers. We already did one, didn't we? With that x cubed. So let's just do that again. So what if our function is x cubed? Then what's that going to look like? We've already done it once, but let's do it again to keep everything all together. So that's going to look like this, and it's going to look like this. Anything with an odd exponent is going to look like this. If it's a positive, okay, if it's a positive and then an odd exponent, your end behavior is always going to do this. It doesn't matter how funky and how big your exponent is, your graph's always going to do this. Your ends of the graph. They might do some crazy stuff in between, all right? But the ends will always do this. So let's write it down again. Let's put it right here. As x approaches, let's go negative infinity again. Do the left, then do the right. Then what does y approach? Negative infinity. As x approaches positive infinity, then y approaches positive infinity. See it? As x goes to the left, y goes down. As x goes to the right, y goes up. We getting this or not?
Okay.
Knocked out about 4 of you now, okay? Doing pretty good. I guess that's good. I don't know. Probably not. All right. Let's do one more. So what do you think I'm going to do to this one now? Yeah, so what's that going to look like? F of x equals what? Negative x cubed. Good. And again, if you got a negative in front of it, and if this is an odd exponent, it doesn't matter what number it is. If it's an odd exponent, it's basically going to do this. It's going to go up like this, and then it's going to go down like this. Let's write the end behavior. So as x goes to negative infinity, what does y do? It goes to positive infinity. As x goes to positive infinity, then y goes to negative infinity. And these are going to be your answers. Excuse me. For the problems that they give you. They're going to give you some crazy looking stuff, but those are going to be the answers to that. I think that is it. Now, they will, I got 5 minutes, okay? I can do this. let me change this over to Desmos. So let's just make up a graph just to see if this really works or not, okay? So y equals, what do you want to do? Let's do an even one first, okay? So y equals x to the, let's not go to the second, that's too easy. Let's go to the 6th power, is that all right? Y equals x to the 6th. We'll just keep it like that. We could add some other things on there as well, but look what happens. Doesn't that do the same thing as y equals x squared would do? Now look, it flattens out a lot at the bottom here. Doesn't look exactly like a parabola, okay, but it keeps on going. So what's my end behavior with y equals x to the 6th? As x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, then y approaches positive infinity. What happens if we put a negative in front of it? It flips it. So again, what's the end behavior? As x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, then y approaches negative infinity. Does it make sense? That's the kind of stuff they're going to ask you to do. But they're going to give you real weird stuff. Let's put an odd one in there. Let's put x to the, x to the, let's get this thing up here, x to the 7th. Oh, why is it making a subscript? I don't know. Let's try again. Y equals x to the, what do we say, 7th? There it goes. X to the 7th. I don't know. Let's put some other things in there. We don't even have to go in order. Like plus, 3x squared minus 3 or something, okay? Crazy looking graph. That might be something like they do. So what do? You just graph it, all right? Do it on your graphing calculator. It's perfectly fine. I don't mind you using Desmos to do that, all right? But look at your end behavior. Isn't it the same end behavior as just regular y equals x cubed? Yeah, it's the same way. It goes up to the right, it goes down to the left. What happens if I put a negative in front of that x? There you go. See, it goes up to the left and it goes down to the right. Same exact end behavior if it was just x cubed. Would you agree? All right? And I could put all kinds of crazy stuff. I could put something to the 6th, x to the 6th, x to the 5th, the 4th, the 3rd. It's going to do some wacky, crazy things inside here, but the ends are always going to go in the same direction. All right, so that's kind of nice for us because it just makes it a little bit easier for us to see those end behaviors. So I told you that was a lot easier, wasn't it? Was it kind of easy to understand? Okay, what we just did? Yeah, I think that was a lot better than that continuity stuff. Okay, for those that stayed awake anyway. All right. That's all I got. Do the homework on that. That's 3.5b, which is numbers, let me see, 20 to 31, right? It's actually for Wednesday, right? It's actually under Wednesdays because we kind of skipped a day because we took a whole day to do an example, or an example. So we're actually looking at Wednesday, so get that done, 20 to 31. Everybody good? All right.